In this video, we'll be looking at what particulate representations of reactions are and how they are used in chemistry. Starting off, what is a particulate representation? A particulate representation is a visual model that shows how individual atoms, ions, or molecules rearrange during a chemical reaction. Basically, we draw out our products and our reactants for our chemical reaction. For instance, this particulate model below, which I have drawn, shows the formation of water through the combination of hydrogen and oxygen gas. This is what it means to have a particulate representation. As you can see, all of our reactants, our hydrogen and oxygen gas, are drawn in here in the left box, and all of our products, that's our water, are drawn in here in the right box. If we're drawing a chemical reaction, there's a few things we really have to pay attention to. Starting off, and probably the most important, are stoichiometric ratios. If our problem gives us a set amount of material, for instance, 4 molecules of water as our product, then on both sides of our equation, and in both of our drawings, we need to make sure that we're accurately drawing 8 hydrogen atoms and then also 4 oxygen atoms. This is how we make sure we're going to follow the conservation of mass. Another thing we have to pay attention to is which bonds are forming and breaking. This is pretty self-explanatory, but you just need to make sure that you're paying attention to which combination of circles will make up our reactant substances and which combination of circles will make up our product substances. And so when I say circles, I'm talking about this thing, our key, which says a red circle is a hydrogen atom, a green circle is an oxygen atom. And so of course, if we want to form a molecule of water, we need 2 hydrogen atoms and 1 oxygen atom, which I've shown here by this combination of circles. So just make sure we're really paying attention to how do bringing our circles together portray the bonds we need to form or break. Also, make sure you're always including all the required molecules. For instance, you should always be drawing spectator ions unchanged on both sides of the equation. And then lastly, make sure that we're always following the key given to us when it comes to drawing our particulate representations. Again, that's this down here. If I want to draw a water molecule, I need 2 red circles and 1 green circle, because that's 2 hydrogen and 1 oxygen. So with that being said, let's now draw some of our own particulate representations. So this question asks us to draw the particulate representation for the products when 4 hydrogen peroxide molecules decompose into water and oxygen gas at room temperature. So I'm going to walk you through this. I'm going to start by writing down my equation. I have hydrogen peroxide, which is decomposing into water and oxygen gas. You'll see that I have to balance this equation, and so I'll just put a coefficient of 2 in front of my hydrogen peroxide and in front of my water. Now my equation's balanced. And so this question is asking me to draw for the products. The products are on the right side of my equation. Additionally, it's asking for when 4 hydrogen peroxide molecules decompose. So if I have doubled my hydrogen peroxide molecules, I can just double the rest of these as well. And so now you'll see in my model, I need to draw 4 water molecules and 2 oxygen gas molecules. And so doing that gives me this final answer. This right here is the particulate representation for the products when 4 molecules of hydrogen peroxide decompose into water and oxygen at room temperature. And so as you can probably tell by now, drawing these molecules is not an inherently intensive or difficult process. All you have to pay close attention to is that you're keeping your stoichiometric ratios and drawing out the chemical reaction accurately. To finish off, let's answer the following question. Given the following diagram of reactants, draw the particulate representation for the products of the reaction were it to proceed to completion. Again, I'm just going to walk you through my thought process. First thing I'm going to look at is this diagram on the right, which shows my reactants. Counting everything up, I see that I have 6 atoms of hydrogen and 6 atoms of nitrogen. Again, that's important because in my final drawing, I cannot have more than 6 atoms of hydrogen and nitrogen. And I also cannot have less than 6 atoms of hydrogen and nitrogen. That needs to stay constant. Next, I'm going to look at this equation because it's going to help me in my final drawing. It reads 2 atoms of nitrogen plus 6 atoms of hydrogen will form 2 molecules of NH3, which is ammonia. And so since I pretty much have all my information I need now, let me draw my box and start drawing my model. The question is telling me that this reaction is going to proceed to completion. So it's going to go as far as it possibly can. So let's just draw this equation and let's see what we now have left. This reaction required 6 atoms of hydrogen. So from my original 6, I'm down to 0. But it only required 2 atoms of nitrogen. So I still have 4 atoms of nitrogen left. So what am I going to do? I'm going to draw these in as my nitrogen gas, my N2. And after doing that, I'm now left with 0 atoms of nitrogen. And so this right here is the particulate representation for this reaction, were it to go to completion with what we were given. So I hope that those two examples have shown that particulate representations are not something you need to be extremely worried about in chemistry. And with that being said, that's all you have to know about particulate representations of reactions for chemistry. If any of this was confusing, I recommend rewatching parts of the video. If it's still not making sense, take a break and come back after. Thank you for watching.